In this chapter, we will talk about information management. We will first start by zooming out and discuss the importance and relevance of information management within the context of the Zachman framework. We will hereby consider the contextual or scope layer, the conceptual or enterprise layer, and finally also the logical or IS functionality layer. Let's start by the contextual or scope layer. Within the scope layer, one needs to determine what information the organization needs. Obviously, this will depend upon the business process. Whether you are working in marketing, HR, production and logistics, or IT, the information needs will be different. However, in all these processes, it is important that the information is qualified and modeled as completely as possible. Completeness is very important. Complete information will allow to make the right decisions at the operational, tactical, and strategical level. Hence, no missing information can be tolerated. On the other hand, one should also avoid information overload. In other words, you should avoid redundant information and make sure that you do not have too much information within the scope. So here it is about finding the right balance between complete information and not overly complete information which is no longer relevant. At the enterprise layer, we will start looking at various concepts, various business concepts. Again, this depends upon the business process you're working in. Let's say you're working in a purchase order administration. Then you have various business concepts which are relevant. The first concept is the concept of a customer. A customer can have certain types of characteristics, such as a customer name, customer number, customer gender, etc. Also, a product concept is an important business concept here. A product can have a product name, a product color, product weight, product description. Also, a supplier could be an interesting business concept here. So each of these business concepts will have characteristics. Besides characteristics, you will also have relations between the business concepts. A customer can place an order. An order can be placed by a customer. Actually, a customer can place multiple orders, and an order is always placed by one customer, let's say. So you have clear relations between those various concepts, and one of the purposes of information modeling, and more specifically conceptual data modeling, is to unambiguously qualify and model all these concepts and the relations between. To this end, we will use various types of conceptual data models. A first important one being the ER model. ER stands for Entity Relationship Model. So it's going to look at your data by defining entity types and relationship types between them, as we will discuss later. The ER model will suffer from a couple of drawbacks, shortcomings, some of which will be remedied by the EER model. The EER model is the Enhanced Entity Relationship Model. Also, other conceptual data models have been introduced, such as the UML model, stands for Unified Modeling Language. UML models are object-oriented models, which are a bit more complex, but also more powerful. We will not discuss UML models in this course. UML models are discussed in other courses on Advanced Management Information Systems or database modeling. At the enterprise level, and at the enterprise layer, in other words, we're going to do data modeling. And here you can see an example of a first data model. Let's say we work out a student administration example. So here we have two important concepts. We have the concept of a student and a study program. Student and study program are here two important business concepts. and there is a relationship between them. A student is enrolled for a study program. Vice versa, the relationship can also be interpreted in the opposite direction. For a study program, you can have enrolled students. So there's a relationship between the business concepts of student and study program. Now this relationship can also be quantified. That is being represented by the numbers you see right there. A student is enrolled for minimum 0, maximum n study programs, or maybe even minimum 1, maximum n study programs. So the minimum number of study programs that a student is enrolled for can either be 0 or 1. That depends upon your business process. So whether it's minimum 0 or minimum 1 is something we need to verify with our business people, with our decision makers that work in the daily student administration. So you can see when we work out a data model, it's very important to define the business concepts, the relationships in between, and also then quantify these relationships as accurately as possible. At level 0, you can then start looking at individual students and individual study programs. You can see that Laura Mitchell is subscribed for the first Master of Information Management. David Peters is then subscribed or registered for the second Bachelor of Business Engineer or Handelsingenieur. When we do data modeling, we will always focus at level 1. We will never work at level 0. We focus at the level where we look at the general business concepts such as student, study program, and the relationships in between. Of course, once our data model has been appropriately defined, we need to start implementing it using an appropriate information system. So here, we can start focusing at the information system's functionality layer. Very important here is the storage. Storage is the first important implementation issue of our data model. Our data model needs to be stored. This will obviously highly depend upon our database design. And as we will discuss later, most typically, our data model will be implemented as a relational model, which will need to be stored as such. Now, once the data model has been stored, we can start working with it. We can start querying the data model. We can start inserting data, removing data, updating data, or selecting data. Imagine, for example, that you would be interested in knowing the names of the students together with their total mark for all students who pass the information management program. That's an example of a query which you should be able to formulate in a straightforward way. A popular language to do so, which we will discuss later on in this course, is SQL. SQL stands for Structured Query Language and allows us to formulate queries in a structured way, according to a predefined syntax. As we will start implementing our information system, we also need to safeguard the quality of the information services provided, and that relates to the input, the processing, and the output. In terms of input, which will mainly occur by means of a transaction processing system, it's very important that the information can be very easily input into the information system. Ease of input is very important. Also, the completeness is important. Every student should have a student name. Hence, we must ensure that student name is not missing as student information is being entered into our information system. Besides completeness, information should also be accurate. When you enter the student gender, only 2 values are allowed, male or female. There's no third value possible. When you enter the address of a student, you need to make sure that the zip code that is being entered is a valid zip code. So as the information is being input through a transaction processing system, it should be complete, it should be accurate, and it should be possible to input the information in an easy way. Once the information has been input into the information system, it will be processed. It will be processed in a decision support system, DSS, or an executive support system. As we start processing the information, it is very important to ensure the correctness of the processing and the reliability. Again, think about the student administration example. It's very important as we start processing students' marks that we do not make any mistakes in there. We want to make sure that students that pass the program actually pass the program, and students that failed the program actually failed the program. Right? So that's really very important. Also, the output, which is usually a report in a management information system, or again in a decision support system, has various key requirements to satisfy. The first one is the timeliness. Imagine that we again focus on the student administration example, then we want to make sure that we can have all the student marks before the exam boards take place. So our information system should allow us to do that. It should provide the reports with all the student marks before the exam boards take place. Also, the information that is being output should have the right level of detail. It should have the right level of selectiveness. If we need information for exam boards, we do not need information about a student's birth date or a student's gender. That's not relevant for that particular process. For the process of an exam board, we only need student names and their marks. The information should also be presented in a comprehensible way. The reports that are being generated should present numbers, data, such that it can be appropriately interpreted by the decision makers either at the operational, tactical, or strategic level. So let's focus on requirement analysis and data modeling. How can we now unambiguously qualify and quantify the information requirements within a particular business process? This will be the subject of the remaining part of this chapter. It is based upon a book by El Masri and Navad, of which you can see the citation right here. You do not need to purchase this book. This is just a book which can come in handy in case you will need additional information. But there's no need to purchase it. Here you can see the overview of the remaining part of the chapter. First, we're going to zoom into the requirements collection and analysis. Then we're going to discuss the importance of data modeling, the entity relationship or ER model, an extension thereof, which is the enhanced entity relationship or EER model, the relational model, and then we will also cover various mappings between those models. Let's first focus on the requirements collection and analysis and work out an example. Let's say you work in a company and you are responsible for a purchase and delivery system. In other words, you need to decide what goods should be purchased when, inspect the delivery of those goods, etc. Well, if you zoom into this process, you will see that you have various activities that relate to the purchase, activities that relate to the delivery, activities that relate to the inspection of the quality, etc. Think of activities such as notification for purchase. If at some point the stock for a particular product drops below the safety stock, a notification for purchase should be generated. This can then be followed by a decision to purchase, which can then be followed by supplier selection, a purchase order that is being made, etc. So you can see that we have various activities, each with their own information needs. Information requirements such as the product number, the product name, the supplier number, the supplier name, the purchase price, the delivery period, etc. So a first step in requirements collection is to identify those information requirements. And that is not a very easy task to accomplish. Retrieving information requirements is difficult, it's not easy. Because as you will start talking to various business people within the purchase and delivery process, you will see that many of them will give you irrelevant info, lack of info, incorrect selection or aggregation level, too much detailed info, too general info, etc. So you'll see that it is really hard to find those information requirements. And that is why there is a special type of job profile available for that. And that's the job profile of the information analyst or information architect. The information analyst or information architect basically bridges the gap between the business process and the IT implementation. He or she sits in between the business people and the IT programmer. He or she sits in between the business people and the database developer. So in other words, this is a person that should have a very multidisciplinary profile. This person should have subject matter expertise. That means that he or she should be capable to understand the business process, be it a marketing process, be it an HR process, be it a production or logistics process. So he or she should have the skills to understand the various activities within each of those processes. On the other hand, he or she should also have a basic knowledge of IT, such that all the requirements within the marketing, HR, or logistic process can be written down into a model, a conceptual data model, which can then be presented or given to the IT or database developer, who can then implement that conceptual data model in an unambiguous way in a physical database. So the information analyst or information architect is not a programmer. The information analyst or information architect will, however, interact with the programmer, will, however, interact with the database designer. So it's very important to realize here that the information analyst or information architect bridges the gap between the business and the IT. Now, information analysts or architects need to very intensively collaborate with the end users. When I say end users, I'm referring to the business people within the particular business process. Think about the purchasing manager, think about the delivery manager, a marketing manager. The information analysts need to closely collaborate with those people to understand their needs, to see what information they require for their operational, tactical, or strategic decision making. And as you, as an information analyst, will start collaborating with those people, you will see that various challenges will pop up. As you start talking to business people, those business people will always refer to existing systems. They have typically a very hard time to think out of the box, to think beyond their own context. And that's very important as you start designing your information system. As you start designing your information system, you also want to optimize the business processes. And you want to start thinking out of the box and see how can we improve upon our current business processes. As you will start talking to those people, you will also see that typically those people will attach much importance to recent information requirements. If they recently faced an information shortage, then they will consider that to be very important. Think about, for example, a purchasing manager that recently was looking for the email of a supplier and could not find it. As you start talking to that person, and that was a situation that annoyed him quite recently, he will consider it to be very important to store the email address of a supplier. So usually people give much importance to recent information requirements. Also, many of those people that work within a purchasing or a delivery process or a chain as part of a whole setup, as part of the whole process. So they only have a very partial, limited view on the process, which also complicates the information requirements collection. Fortunately, there are a couple of techniques that can assist us with this. And the first one is observation. That means that as an information architect or analyst, you're going to immerse yourself within the business process and start observing people. In other words, you step into the business environment, you go to a particular firm, you go and inspect a particular magazine or you go to a particular firm and you're gonna immerse yourself in the business process by observing how the people work. How do they select a supplier? How can they see that certain products are about to drop below the safety stock? So you observe. Another key activity to collect information requirements is by interviewing. You start talking to the purchasing manager, to the delivery manager, and talk about their information needs, either in an informal or a formal way. If it's formal, you can do it by means of a survey. The survey can be anonymous or not anonymous. Maybe if it's anonymous, people will give you more useful information. More useful information about how the current business process might be improved. Also, document analysis could be considered. Documents could be physical documents or emails. Document analysis refers to inspecting the documents, inspecting a purchase order, see what is being mentioned on the purchase order. What are the information requirements, the information items which are being specified on a purchase order? A delivery notification. How does that look like? Is it a physical delivery notification or is it an email? All those things can then also be complemented with brainstorming. Brainstorming means that you organize very focused sessions with a few business people and start thinking about how you can improve the current business process. What are the current information needs and what could be interesting information to add on to those information needs. There also exist very structured ways to assist with this. The Delphi method is one of them. This is a structured interview in order to reach a consensus or to formulate extreme views but with well-founded arguments. Also, techniques from the area of decision analysis, such as operations research, can be useful here. Prototyping refers to developing a prototype information system. Think about a GUI, a graphical user interface with buttons, with boxes, with drop-down lists, but with no functionality behind that. So if you push a button, nothing's going to happen. So a prototype is a quick design of an information system that you can present to the end users and that you can use as a discussion tool during the brainstorming or during the Delphi sessions. Decision tables or tabular representations which represent the decision logic of a particular business process, like how is a supplier being selected? What is the importance of the price? What is the importance of the reviews of the supplier? What is the importance of the delivery term of the supplier, and so on. Decision tables allow you to actually represent the whole process of selecting a supplier. That could also be very handy as you start qualifying your information needs. So in other words, what we're going to do here is we're going to qualify all those information needs by developing a conceptual data model. Let's just read what's on my slide. What do you want to do when you develop a conceptual data model? When you develop a conceptual data model, you want to capture the semantics of the universe of the scores as accurately as possible without being concerned about database software related issues. That looks like quite difficult, so let's just go through that once more. You capture the semantics of the universe of the scores. What is the universe of the scores? This is the business context, the setting you're working in, the marketing process, the purchasing and delivery process, the HR processes that you would be interested in, like a personnel administration. So the universe of the scores is the business process you're interested in, and you want to capture the semantics of that process as accurately as possible, and you're not being concerned about software related issues. So that means that you're not concerned whether the actual implementation will be an Access, Microsoft Access database, an IBM database, and so on. Your only goal at this moment is to understand the business process, understand its information or data needs, and formulate those in an unambiguous, formal data model. And one model which is very handy in this context is the ER model, the entity relationship model. The entity relationship model is a perfect model to communicate with your business people and your IT people. Your business people will be able to understand the ER model, and your IT people will be able to implement the ER model. In a later stadium, your IT people will take the ER model and map it to a relational database model. Now, what a relational database model is, we haven't discussed yet, but we will discuss it later. Within the context of the Zachman framework, this relational database model is situated at the layer of the logical IS functionality, but we'll zoom into that later on. What is the ER model? Well, it's a formalism to build a conceptual data model. It's quite popular in the industry, and actually, it is also already quite old. It was developed by a person called Peter Chen in 1976, so it's quite old already. It has been very successful. Why has it been so successful? Because it combines a realistic view with a high degree of formalism. In other words, the realistic view is very important for the business user because he or she will also be able to understand the entity relationship model. And a high degree of formalism is needed for our IT guy because he or she will then be able to unambiguously implement the ER model in a database model. So it's a compromise between expressivity and comprehensibility. And it has three very important components: entity types, attribute types, and relationship types. And what makes it also very attractive is that it has a very comprehensible, easy to understand graphical representation thanks to the ER diagram. Various extensions have also been provided, such as the enhanced entity relationship model, as we will discuss later on. But first, let us just work out an example of an ER model. Here you can see an example of an ER model. Let's assume we again focus on our purchase order administration. As I said, the first thing you should do there is you should define all the business concepts. Well, what are the business concepts? Let's simplify things a bit, and let's say we only want information about three business concepts: supplier, product, and purchase order. These are the three business concepts that we would like to store information on. A supplier has various characteristics. A supplier has a supplier number, a supplier name, supplier city, supplier address, and supplier status. These are what we refer to as the attribute types. The business concepts are the entity types. Supplier, product, and purchase order are the entity types for which we would like to store information. Each of the entity types has attribute types. Purchase order has purchase order number and purchase order date. Very important is that we focus here on the types, on the entity types. We will not focus on the individual entities. So we focus on supplier as an entity type. An entity would be a particular supplier. John Smith is an entity. He's a supplier entity. Sarah Adams is a supplier entity. Pencils could be an example of a product entity. Pens could be an example of a product entity. So we are not going to focus on the individual entities, but we focus on the entity types: supplier, product, purchase order. So each of those entity types has attribute types. Some of these attribute types are important and underlined. These are what we refer to as the key attribute types. A supplier has a unique supplier number. That's why the supplier number attribute type has been underlined. It's a key attribute type. Given one particular supplier number, we can identify one particular supplier. Every purchase order has a unique purchase order number. That's why purchase order number has been underlined, because it's the key attribute type. Every product has a unique product number. That's why product number has been underlined, because it's the key attribute type. As we already said before, once you have identified those business concepts, you will also see that there exist relationships between those business concepts. A supplier can have various purchase orders on order. A purchase order can be on order with a particular supplier. So that's a relationship type between supplier and purchase order. A supplier can supply various products. A product can be supplied by a supplier. There's also a relationship between product and purchase order. A product can be included in a purchase order. In a purchase order, you can have products included. So you see that those relationships actually model connections between the entity types. The relationships are being represented by a diamond, which you can interpret as two adjacent arrows. Two arrows pointing in each direction of the relationship. Those relationships can now also be quantified. That means that we can attach numbers to them. Let's have a look at the relationship type between supplier and purchase order. First, we go from supplier to purchase order. So we take the arrow downwards. A supplier can have minimum 0, maximum n purchase orders on order. So there you can see 0n next to purchase order. Supplier can have minimum 0, maximum n purchase orders on order. Vice versa, so now let's interpret the relation in the opposite way. A purchase order can be on order with minimum 1, maximum 1 supplier. Minimum 1, maximum 1 is the same as saying exactly 1. So a purchase order can be on order with exactly 1 supplier. Those numbers are what we call the cardinalities. And we have a minimum and a maximum cardinality. So a supplier has a minimum of 0 purchase orders on order. So the 0 is the minimum cardinality, and a maximum of n purchase orders on order. So the n is the maximum cardinality. A purchase order can have multiple purchase order lines. So now we're looking at the relationship type between purchase order and product. A purchase order, in a purchase order, you can have minimum 1, maximum n products being ordered. Right? Minimum 1, maximum n products being ordered. Vice versa, the relationship can be interpreted in the other way. A product can be ordered in minimum 0, maximum n purchase orders. Finally, we also have the relationship type between supplier and product. A supplier can order minimum 0, maximum n products. A product can be ordered by minimum, let me do that again. A supplier can supply minimum 0, maximum n products. A product can be supplied by minimum 0, maximum n suppliers. Some of these relationship types can also have attributes. If you look at the relationship type between supplier and product, so this relationship type is called supplies, upper right corner of the model, you can see that this relationship type has two attribute types, delivery period and purchase price. These are characteristics of the relationship type. These are attribute types of the relationship type. So, in order to know both the delivery period and the purchase price, you need to know the supplier and the product. Imagine that you have a supplier, John Smith, and a supplier, Sarah Adams, and you have products, pens and pencils. All suppliers, John Smith, Sarah Adams, can supply pens and pencils. So in order to know the price for a particular product, you also need to know the supplier. So John Smith can actually supply pens at a price of, I don't know, €5 and a delivery period of 1 month. So the delivery period and the purchase price are two examples of attribute types which you cannot connect to the entity types, either supplier or product. They are attribute types which are connected to the relationship type, because in order to know the delivery period and the purchase price, you need to know both the supplier and the product. Likewise, if you look at the relationship type between product and purchase order, this relationship type also has a name, which is called purchase order line. And this relationship type also has a quantity attribute type. This is an attribute type which connects to the relationship type. In order to know the quantity, you need to know what product and what purchase order. So the purchase order is needed together with the product to know what quantity. A product is being ordered in a particular quantity in a particular purchase order. So the quantity attribute type can also not be shifted to either the product or purchase order entity type. This is an example of an ER model. And let's just say a few more words about it. You can see it's very user friendly. It's very easy to understand this ER model. So it's a very handy tool to start communicating to my end users. By giving them the basic rules of an ER model, they will be able to perfectly understand it. Also, when I have this ER model, I can basically give it to my IT guy who will make a database application out of it. My IT guy can very easily take this ER model and build a Microsoft Access, an Oracle, or an IBM database with it. It's a very user-friendly model. It's also very unambiguous. So the end user, the business user, will help us define all the entity types like supplier, product, and purchase order. He or she will also help us define all the attribute types, the ones which are relevant. And he or she will also help us define the relationship types together with the cardinalities that come with each of the relationship types. Okay, so now you understand the ER model from a high-level perspective. So let's now provide some further detail. In the ER model, the first important concept or entity types, and an entity is an object in the real world with independent existence. It can be physical, such as a customer, such as a supplier, or it can also be conceptual, such as a company, a job, or a university course. Each entity has properties or characteristics. Think about an employee administration. Then an employee can be described by the employee's name, age, address, salary, college degree, and job. These are what we call the attributes. Okay. Some of these attributes can have null values. Be very careful here. When we say null values, we are not referring to zero. We are referring to a value which is unknown or irrelevant. Think about a supplier and an attribute email address. Let's say that the email address is unknown, then this supplier, let's say John Smith, will have a null value for email address. So very important is that null is not equal to zero. It just means an unknown or irrelevant value. Also, when we talk about modeling, it is really very important to distinguish between the ideas of a type and an instance, which we earlier referred to as level 1 versus level 0. Let us just actually illustrate this with the next slide. At level 1, we focus on the business concepts. We focus on the type. So here you can see an employee type and a department type. At level 0, you can focus on individual instances, individual occurrences. So John Smith is an employee. Lee Wong is an employee. James English is an employee. Logistics is a department. Finance is a department. These are instances. These are occurrences of the type. An employee can be instantiated into John Smith, Lee Wong, James English. A department entity type can be instantiated into logistics, finance, marketing, or R&D. The other way around is classification. John Smith, Lee Wong, and James English can be classified as employees. Logistics, finance, marketing, and R&D can be classified into departments. As I already said, when you do data modeling, you always focus on the level of the type. You look at the types, not at the individual occurrences. Just as you have a distinction between an entity type and an entity, you will also have a distinction between an attribute type and an attribute. Product color is an attribute type. Blue is an attribute. Green is an attribute. Employee name is an attribute type. John Smith is an attribute. Department name is an attribute type. Logistics is an attribute. So here you can see the difference between classification and instantiation. Just to give you another example, here you can see it being visualized in Microsoft Access. We have employee and department. These are the types. In Microsoft Access, you can then see the employees, Thomas Torres, Ernest Rees, Julie Parks. These are all employees. Right? You can then have various departments as well. So it's very important to be aware of this distinction here. Let's say a few more words about attribute types. Attribute types can be composite or atomic or simple. Simple and atomic are synonyms here. Simple means that the attribute cannot further be decomposed in a meaningful way. Salary, this is just a number, cannot further be decomposed. Composite means that the attribute type can further be decomposed in a meaningful way. Name can be further decomposed into first name and family name. Address can be further decomposed into street name, street number, zip code, city, and country. How do you know whether an attribute type is composite or simple? Well, it's the business person who will tell you this. The business person will tell you, hey, I want to store address, but I would like to make sure that I have information about the city such that I can easily later on query all suppliers which are originated in Bruges, Belgium, for example. So if your business user tells you that it's really important to also individually store the street number, street name, zip code, city, and country of your suppliers, then you know that address is a composite attribute type. And you need to model it as a composite attribute type composed out of street name, street number, zip code, city, and country. Attribute types can also be single-valued versus multi-valued. Single-valued means that you have only one value, such as age, and actually, to be more precise, that should be date of birth. Every person has only one date of birth. A multi-valued attribute type, as the term suggests, can have multiple values, like college degree. More and more students have multiple college degrees. So in other words, we can model this as a multi-valued attribute type. Email address can also be a multi-valued attribute type. Students usually have multiple email addresses. They have a Gmail, Yahoo address, and so on. Note that you can also have a multi-valued composite attribute type. If a supplier has multiple addresses, then this becomes a multi-valued composite attribute type. It's an attribute type which is composite, and on top of that has multiple values. Another important attribute type, which we already briefly referred to, is a key attribute type. A key attribute type is a collection of one or more attributes whose values can be used to uniquely identify each entity. Every employee has a unique social security number. So using social security number, we can uniquely identify an employee. So social security number is a key attribute type here. Note that a key attribute type can basically consist out of multiple attribute types. Think about the following. There we have a flight entity type, and it has two attribute types, flight number and date. Let's say we look at SN Brussels Airlines. SN Brussels Airlines operates flights within Europe and also to Africa and the US. What is now the meaning of a flight number for SN Brussels Airlines? So let's say that the business of SN Brussels Airlines is as follows. Let's say you have a particular flight, SN 100, that's a flight number, and that's a flight between Brussels and New York. Well, SN 100, we have a flight today, let's say, between Brussels and New York with flight number SN 100. We have a flight tomorrow with the flight number SN 100, and so on. So in other words, every day there is a flight SN 100 going from Brussels to New York. So the question is, can we now uniquely identify a flight only with the flight number? Well, obviously we cannot, because today there's a flight SN100 from Brussels to New York. Tomorrow there's a flight SN100 from Brussels to New York, and so on. So flight number is not sufficient as a key attribute. So what about date? Is date sufficient as a key attribute? Could we say today and look at today's date and say this is the key attribute that allows us to uniquely identify a flight? Well, obviously not, because today you will have multiple flights. So nor flight number nor date is sufficient as a key attribute. So in this particular setting, we need the combination of both. Given a particular date, today, and a particular flight number as N100, we can uniquely identify a flight. So where do you get your key attributes from? You get them from the business. You have to ask the guy from the business, what is the meaning of a flight number in SN Brussels Airlines? Is it a unique number within a day, or is it a unique number within the whole business context? Let's say that SN would just consequently number its flights from 1, 2, 3, and so on. It keeps on adding new numbers once it actually has a new flight. Then in this particular setting, flight number would be unique and would be sufficient as a key. So whether your key is a combination of two attribute types or just one attribute type is not something you decide as an information architect or analyst, but it's something that the business has decided for you. And that's something that you then have to capture by making sure that you correctly identify the meaning and then as such define your key. Every key attribute type must satisfy a uniqueness constraint. And with a uniqueness constraint, we mean that every entity should have a unique value for the key. Here you can see some attribute types in Microsoft Access. You can see two entity types, units and docents or lecturers. And then you can see to the right, you can see some attribute types such as a lecture ID, lecture name, lecture unit ID, which each have a particular data type such as number, text, and number. So now we've covered attribute types and entity types, but remember in the ER model you also have relationship types. A relationship type defines a connection between entity types. So it's a set of homogeneous associations among entity types. And again, you can have the distinction between a relationship type and a relation. A relationship type could state a student follows courses. A course can be followed by students. A relationship would then mean John Smith follows database management, business information systems, etc. So a relationship is an instance of a relationship type or an association. To facilitate the interpretation of your ER model, it is very important that a relationship type has a name. For example, the relationship type on order models the association between supplier and purchase order. The relationship type supplies, as we referred to it earlier, models the relationship between product and supplier. Relationship types themselves can have attribute types. We said that before. If you look at the relationship type supplies, which is a relationship type between supplier and product, then you may still remember that it had attribute types such as delivery period and purchase price. Attribute types of relationship types can only be determined by the combination of the participating entities in the relationship instance. They cannot be moved to any of the participating entity types. So we cannot just move delivery period and purchase price to either supplier or product. The degree of a relationship type is the number of participating entity types. That could be 1. That's quite weird. Can you have a relationship type with only one entity type? Well, in fact, you can have that. I'm going to explain that later on. Let's just leave it there for the moment. All of the relationship types that we have discussed thus far are binary relationship types between product and supplies, between product and supplier, between supplier and purchase order, and between product and purchase order. All of them had two participating entity types and are thus binary relationship types. You can also have ternary relationship types, but we will not discuss this in this course. This is part of a more advanced course. Every relationship is being represented as a diamond, which can actually be interpreted as two connected arrows. An arrow that goes up or down or left or right. These are what we refer to as the association types or roles. They help to explain what the relationship means. For example, the association on order between supplier and order can be considered both starting from supplier as well as starting from purchase order. Each role has a name. Relationship type on order has the roles from supplier to purchase order, and vice versa, the other arrow from purchase order to supplier. Relationship types can also be quantified, as I explained. The way you're going to quantify a relationship type is by means of cardinality ratios. Cardinality ratios specify the minimum or maximum number of relationship instances that an entity can participate in. What I will do right now is I will explain the minimum maximum cardinality by means of this example. So here we have two entity types, supplier and purchase order, and we have a relationship type visualized by means of the diamond. And you can see the diamond is basically two arrows, an arrow pointing to the right, arrow pointing to the left. The name of the relationship type is on order. A supplier can have minimum 0, maximum n purchase orders on order. The minimum cardinality is 0, the maximum cardinality is n. A purchase order is on order with minimum 1, maximum n. Let me do that again. A purchase order is on order with minimum 1, maximum 1 suppliers. So that's exactly one supplier. So the minimum cardinality is 1, maximum cardinality is 1 as well. So the minimum cardinality can either be 0 or 1. The maximum cardinality can either be 1 or n. If the minimum cardinality is 1, we have existence dependence. Purchase order is existent dependent on supplier because the minimum cardinality there is 1. You cannot have a purchase order without a supplier. The existence of a purchase order depends upon the existence of a supplier. Purchase order is existent dependent on supplier. Supplier is not existent dependent on purchase order because the minimum cardinality from supplier to purchase order is 0. So I can perfectly have suppliers which are not connected to purchase orders. That's what we call when the minimum cardinality is 0, we refer to that as partial participation. Some suppliers will participate in the relationship type and be connected to purchase orders. Other ones will not participate in the relationship type and not be connected to purchase orders. So in terms of cardinalities, there are 4 combinations that you can think of: 0 to 1, 0 to m, 1 to 1, 1 to n. Oftentimes, relationships will be described in terms of their maximum cardinalities. Here you can see, in this particular case, we would say that this is a 1 to n relationship type because the maximum cardinality here is 1 to n. So you can perfectly use the maximum cardinality to refer to the relationship type. Here you can see another example of a relationship type. Employee. An employee always works in minimum 1, maximum 1 department. The minimum cardinality is 1, maximum cardinality is 1, so that means an employee works in exactly 1 department. In a department, we have minimum 0, maximum n employees working. Remember, where do you get those cardinalities from? You get those cardinalities from your business environment, from your business user, from your business process. Bottom of my slide, you can see how those relationships can be drawn in Microsoft Access. You can see the connection between two tables there, units and docents or lectures. Earlier on, we introduced the idea of a recursive relationship, and we said this is a relationship type where the degree is 1, and that was pretty weird, right? So how can you have a relationship with only one entity type? Well, here you can see an example of that. This is basically an entity type employee, and let's say that we would like to model the hierarchical relationships between our employees. So we would like to model the supervision relationship. So here we have a relationship type, supervision, and it says the following. An employee supervises minimum 0, maximum n other employees. Vice versa, an employee can be supervised by minimum 0, maximum 1 employee. Let us do that again. So an employee supervises minimum 0, maximum n other employees. An employee is being supervised by minimum 0, maximum 1 employee. And there you can see some example employees. You can see, for example, Rick Torfs supervises Danny Peters. Danny Peters supervises Luc Sells. Luc Sells will then supervise, he's the dean of our faculty, the various professors of the faculty. So he supervises multiple people. Vice versa, a person is only supervised by minimum 0, maximum 1 person. So you can see those unary relationships, those recursive relationship types come in quite handy here to model the hierarchical responsibilities between employees. One more thing to add is about the difference between a strong entity type and a weak entity type. And I will explain this with the example on my next slide. I would like to start with the example to the right, where I have a hotel entity type and a room entity type. A hotel has a unique hotel name. Let's say Holiday in Leuven, Holiday in Brussels, Holiday in Ghent, Holiday in Antwerp, and Holiday in Bruges. These are examples of unique hotel names. Then we have room, and there's a relationship between hotel and room. Well, a hotel can have 0 to n rooms, minimum 0, maximum n rooms. That's kind of weird. Can you have a hotel with 0 rooms? Well, you can. Let's say that our business guy, the hotel chain manager, tells us, well, we are building some hotels and they haven't got rooms yet, but because they're still in construction, but we would like to store information on those hotels. So despite the fact that the hotels do not have rooms, we would like to store information on them. So there could be hotels that have 0 rooms. The minimum cardinality comes from our business requirements. Obviously, a room cannot belong to multiple hotels. So a room belongs to minimum 1, maximum 1, or exactly 1 hotel. Okay. A room has a room number. It could be 1, 2, and so on. And I asked my guy from the business, my hotel chain manager, I asked him, can you give me some more information about how rooms are being numbered? And then he says the following. He says, if I look at my hotel in Leuven, Hotel Holiday in Leuven, the rooms are numbered from 1 to 200. If I look at my hotel in Brussels, then the rooms are numbered from 1 to 500. In Antwerp, from 1 to 100, etc. So if I then start thinking about my key attribute type, every hotel obviously has a unique hotel name, but the room does not have a unique room number, right? Because if I look at room number 50, I will have a room number 50 in the Holiday in Leuven. I will have one in Holiday in Ghent, one in Holiday in Antwerp, etc. So only with the room number 50, I cannot uniquely identify a room. That's why we call room a weak entity type. It's a weak entity type because it cannot come up with its own key. It does not have sufficient attribute types to identify itself. It does not have its own key attribute. So what we're going to do here in this particular setting for room is we need to borrow hotel name from hotel. Room is existent dependent from hotel, and it needs to borrow hotel name from hotel in order to be able to define a key attribute. So now the key attribute for room becomes the combination of hotel name and room number. Both these attribute types now allow me to uniquely identify a room. Okay, so a weak entity type is an entity type that needs to borrow an attribute type from a parent entity type, in this case hotel, in order to come up with its own key. A weak entity type is always existent dependent. That's pretty obvious because it needs to borrow the key attribute from the parent entity, so that That's what makes it existent dependent from this parent entity type. Remember, existent dependent means that the minimum cardinality is 1. So if you look from room to hotel, then the minimum cardinality is 1 because of the existent dependency. Okay, so a weak entity type is always existent dependent. So that brings us to the next point. Is an existent dependent entity type always weak? And now we can look at the ER model to the left of this slide. And there you can see supplier and purchase order. We've already talked about this. A supplier can have minimum 0, maximum n purchase orders on order. A purchase order is always on order with minimum 1, maximum 1 supplier, or in other words, exactly 1 supplier. Purchase order is existent dependent from supplier because the minimum cardinality is 1, right? You cannot have a purchase order without a supplier. The existence of a purchase order depends upon the existence of a supplier, which is perfectly captured by the minimum cardinality of 1. So is purchase order now a weak entity type? It is not, because purchase order has a purchase order number. And a purchase order number allows me to uniquely identify a purchase order. So it's definitely not weak. So here we have an example of an existent dependent entity type which is not weak. To summarize, a weak entity type is always existent dependent. An existent dependent entity type is not always weak. That's the point I wanted to make right here. Here you can then see an example of an employee administration. So we have various entity types: employee, project, department. Each of them with their attribute types. Employee has social security number, employee name, employee address. Department has department number, department name, department location. And then we also have project with project number, project name, project duration. The key attributes have been underlined. For employee, this is social security number. For project, project number. For department, this is department number. For employee, we have this recursive relationship type, supervised by and supervises, which we already explained before. There's also a relationship type between employee and department. An employee works in minimum 1, maximum 1 department. In a department, I have minimum 1, maximum n employees working. An employee manages minimum 0, maximum 1 department. A department is managed by minimum 1, maximum 1 employee, or exactly 1 employee. An employee works on projects. An employee works on minimum 0, maximum n projects. A project is being worked on by minimum 0, maximum m employees. The works on relationship type also has the number of hours that an employee works on a particular project. Project is being assigned to a department, minimum 1, maximum 1 department, so that's exactly 1 department. The department is in charge of 0 to n projects. Okay. This is an ER model. What are now the drawbacks of an ER model? Well, the first drawback is that an ER model gives you a snapshot in time of a situation. It does not allow to model time-dependent patterns. Temporal rules. Temporal, you can see that there's the idea of time in there. What's an example of a temporal rule? An example of a temporal rule could be an employee needs to be assigned to a department after 6 months. Let's say that newcome employees are first being rotated across the various departments, and after 6 months they need to be assigned to a department. Then we have a temporal rule that states an employee needs to be assigned to a department after 6 months. This cannot be captured in the ER model. Other example of a temporal rule. An employee cannot return to a department of which he or she was previously the manager. That's another temporal rule. So any aspect related to time cannot be captured in this ER model. Another drawback of ER is that it cannot enforce integrity rules that span multiple relationship types. Let's have a look at the relationship type works in and manages between employee and department. It speaks for itself that an employee should always work in a department that he or she manages. This cannot be enforced in the ER model. According to the ER model, it is perfectly possible that you have an employee, Bart Baesens, working in marketing, and managing IT. This is inconsistent. This should not be the case, right? If an employee manages IT, he or she should also work in IT. Well, our ER model does not allow us to enforce this very simple rule. There's also a rule which actually spans the three relationship types: works on, in charge of, and manages. And again, the rule is very straightforward. The rule states an employee can only work on projects assigned to departments to which the employee works. So the rule spans the relationship types works on, in charge of, and works in, actually. An employee can only work on projects assigned to departments in which the employee works. That's a rule that spans multiple relationship types and which is pretty obvious as you hear it, but it cannot be enforced in our ER model. So you can see that our ER model clearly has some shortcomings here. These are again nicely summarized right here. The ER model presents a temporary snapshot. Temporal aspects cannot be modeled, such as an employee needs to be assigned to a department after 6 months, cannot return to a department of which he or she previously was a manager. Also, integrity rules across multiple relationship types cannot be enforced. An employee needs to work in a department he or she manages, and employees must work on projects assigned to departments to which the employees belong. To summarize, here you can see some of the notation, the summary of the ER diagram notation. Maybe we haven't covered all of that, but we've covered the most important notations for entity types, weak entity types, marked with the double line, attributes, key attributes, etc. To finish this chapter, this part on ER modeling, here you can see the methodology that you're typically going to adopt for designing an ER model. You're going to first determine and name the entity types. A very useful rule here is to look at the nouns in the textual description of the business process or activity. Then you determine and name the relationship types. You name the roles. Remember, every relationship type can be interpreted into two directions. You determine the cardinalities. Determine and name attribute types and connect attribute types with entity types or relationship types. And then finally, you indicate the key attributes. This finishes this first section on ER modeling.